So when there is the IS code, as I discussed, 9103, which is required for your chemical admixture, and these are the requirements they are specified. One is water content. So once you are using these admixtures and they are specifying this particular admixture is gives you water reduction 10%, 15%, 25%, or 30%. How to verify that? Whether really it is something, this basically it is the water content we are talking about. So when you do the one mix, and that's called control mix within X amount of water, and then whatever admixture supplier is specified, suppose he gives 10% reduction with his admixture using suppose 1%, then prepare a concrete, reduce water 10% and see for the equal workability whether it is you are able to achieve. If not achieve, then we'll have to work out what reduction they give. So that is a requirement of particular admixture, whatever specified. Similarly, slump requirement is also there. With the control, how much increased slump will get. There are two things. One is you get reduced water content, or you keep same water and increase your workability. So that is also possible, or slump. Then setting time, you can take initial and final setting time, how much is there. These all are given in IS 9103. You can refer that table. I am not going in detail because if you discuss same table, it will come more than 1 or 2 hours minimum. Okay. So setting time is important. So when you are working in winter, the admixture we are using for summer may not give same setting time in winter because ambient conditions have changed. So one has to modify the admixture for the particular ambient conditions. Accordingly, we have to discuss with the admixture manufacturer. Now winter is approaching. You change your admixture and give it to me for the particular application. So that has to be monitored. We cannot use same admixture throughout the year. And final setting. Initial setting time, we are not able to vibrate the concrete. After that, in final setting, we can de-shutter your verticals at least. Structural member we cannot do, but at least vertical member, columns, uh, beam sides, not bottom. Sides can be de-shutter after final set. That may be about 10 hours, 12 hours, 18 hours, 24 hours, depend upon the mixed proportion as well as the ambient condition. Then increase with the compressive strength. That also we can check with control and this. If there is any polymer content, it may give more strength with the same water cement ratio. So you reduce the water content, reduce the cement content, you may get similar strength of control. So that is the capacity of that particular admixture, including flexural strength, that is the tensile strength. Mostly we use for designing road concrete. All your pavement quality concrete designed for flexural strength, not for compressive strength. Then length change, there is a shrinkage. When the water is reduced, shrinkage may be less compared to the control concrete. So shrinkage also will have to check length change. Bleeding, bleeding I think we have discussed in some part in we have discussed, but further what is the bleeding, how to trace the bleeding, we'll discuss in when you discuss about fresh properties of concrete. But this test is given in IS 9103. Find out what is the bleeding in the concrete. Bleeding is nothing but when you place the concrete, the clear water is coming on the surface and remain at the top of the surface is called bleeding. Now this may be possible because of admixture, or sometimes may be possible about your mixed proportions are not proper. Or there is a void within the system of paste, fine aggregate and paste. So with the capillary action, the lacking in fines, suppose aggregates are there. There no fines is there below 150 micron or below 300 micron. Material is lacking. You will find most of the time you will get bleeding. Now, these also can be arrested using your admixtures. That's what we discuss. Loss of workability we have discussed. This is a retention. I want 1 hour, 2 hours, 3 hours. So once you are working on a project, you will find that my particular application I need 4 hours. So when you are designing in concrete, in laboratory, you design for 4 hours. Now once you design, you take a plant trial and see whether in the field I will get similar performance of that particular concrete. And then you can. So loss of workability you have to check, because certain admixture may get immediate flow, and within certain time, maybe within half an hour, there is a drop drastically, which is not good for concrete. Whether we are using RMC, or there is a certain minimum time is required for the handling concrete. Rather. Then air content, as I said earlier, air is the cheapest admixture to be used in concrete to increase in the workability. Even your normal liquid soap you add into the concrete, you will find concrete become a workable. Most of the time when you make a plaster, the cheap quality of admixture, they use only a air entering agents. So in, because these all tiny air bubbles work as a lubricant on the particles and gives more flow. This very fluffy plaster will get, and mason has to be very smoothly can work. But there is no interconnected porosity in the mix. That one has to understand. Though air is there, but that is not interconnected. So permeability is not there, but there is a porosity in the concrete. But there is a very, very micro level air bubbles are there. So then one has to see that. So general guidelines for using admixtures. Now this one has to see same type of admixture from different manufacturer may require different doses to achieve desired effect. Though the type is same, so once you change your manufacturer, one has to see the effect, because they may dosage may different, because their solid content may be different, their ingredients whatever they have prepared may be different, maybe certain are there but minor ingredient may affect the performance in concrete or different dosage. So that one has to see very carefully using your admixtures. You cannot change your admixture at frequent level. You'll have a lot of problem at execution level. Now the effect of admixture depend on the particular cement and other additions like fly ash, GCBS, microsilica, microfine materials, whatever you use. Now this is a major effect of admixture performance is your particular admixture compatible with the particular source of cement. That one has to clearly remember this. Compatible of the compatibility of the admixture with particular type of cement is very, very important, because cement chemistry and admixture chemistry, if they are not aligned properly, you make a different performance. Individually, both admixtures are meeting the requirement as per the standards, but when they mix together or work together, they may not match. The performance is different. So suppose there is a same cement manufacturer, suppose ACC is there, for example, they have got plant at Wadi at Karnataka, another plant at Chandrapur. Now if you use say one admixture which may work with Wadi, may not work with Chandrapur cement, because their chemistry is different. Raw materials are different. Manufacturing raw material of particular cement. So that one has to remember very clearly. How to test it, we'll come to that next. So compatibility of admixture, every time you'll listen this to admixtures, compatibility of cement with the admixture. So when you are ordering any admixture, you have to tell which source of cement you are using for your concrete. And they have their own backup data with admixture manufacturer. Depend upon your location, they will say yes, with this requirement, you use this particular admixture. For that, definitely you have to take a trial, but they will suggest very near to the requirement because they have their own backup data with them, which area, which cement you using, and which admixture is moving in the particular market. So you cannot change. Now, suppose cement change, same admixture may not work, may work, may not work. So one has to check the compatibility and then only proceed for production. Otherwise, you will have a lot of issues in concrete. Now, this admixture, range of admixture for particular type and brand of admixture also to be fixed. Admixture supplier change, may the dosage may be changed. Now, sometimes you are using combination of admixtures also. That is also important. Suppose I use only super plasticizer and my long haulage is there 3 to 4 hours. Suppose I have to supply concrete from Mumbai to Pune and transit I required 4 hours. Concrete should not set. It's possible. So I can use super plasticizer and retarder separately. So I can add only retarder in the batching plant. So concrete will not set for 4 to 5 hours. Once it is reached at the site transit mixer, I can add super plasticizer, okay, regain my workability. I can use it within an hour or so. So that is possible. So that also is important to understand. Depend upon your application, you can design your or you can mix proportions with various admixture to get a particular performance at the particular application. Possible. Now, big, very big projects. What is happening? You are consuming huge material of cement as well as admixtures. So initially, you do a lot of trials in your laboratory and found particular admixture suitable for particular source of cement. So it is always advisable that you should have about 2 or 3 sources of cement and 2 or 3 sources of admixtures compatible with different cement. So on when the project is moving, will not have any hurdle in between. Suppose some particular source is not coming due to the various reasons. Even admixture is not available, you can use alternate admixture without loss of any time because backup data is available. So when you are evaluating this material initially, you evaluate at least 3 sources of cement and 3 sources of admixtures and check their compatibility. And once we have found out that this particular admixture is suitable for this source, that reference sample you can keep in your laboratory always. At least 5 to 10 liter sample you keep in your laboratory, putting all the references, details. And whenever the new lot comes, we have to check the performance with this particular standard sample, standard reference sample, and the new lot. Because we don't have chemistry lab at the site, project site. We have only a performance. You can see in the mortar or you can see in the concrete. So once you have particular cement, which admixture you are approved, you can keep that reference sample and compare with the whenever a lot is coming, we can compare with that. And once it is meeting the requirement, then only we can proceed for admixtures or production. So this is very important that reference sample always you have to keep and keep a reference concrete also. You cannot go only by the supplier's quality certificate. This is not very useful to you. Some of the admixture manufacturers, they may not have the facility to test their raw materials, because most of the raw materials coming imported. If there any variation in raw material itself, they will find there is a performance variation of the in concrete. Small manufacturer, what they do, they blend this material and give it to you. So they may not having facility for testing admixtures raw material. You may do XRD, XRF, lot of things you will required, but that facility may not available. So you have to check only performance by your physical performance in concrete. And this is one of the tests they are given for freezing and thawing system. Basically, when you are working for cold weather conditions, tests they are given in IS code today, they are included, so that you can go through that. Then there is a flow test. Now, when you are using such a admixture like PC admixture or pyrocarbo, polycarboxylate ether, is called PCE, we require to have a more workable concrete, high workable concrete. Now, whenever there is a slump more than say 180, 200, it's very difficult to test by the slump itself, slump test. So there is a flow table test is given in the IS code. This is the dimension of that, and this is the flow table here, and there is a lifting arrangement here. So once you place this, we can lift to 40 mm from the bottom and drop it. So you make 15 times and see the spread. That is called flow test, which is given in 9103. Now also it has included in IS 1199 2018. That new code has come. Now this test has added into that particular. So how to work for the high workable concrete. When you talk about fresh properties of concrete, we'll discuss in detail about this. I'll just show a few slides about that. This is your flow table. This is similar to the slum cone, but height is less and tamping rod is different. You must have seen slum cone tamping rod. This is a different, and this height is adjusted to 40 mm. So you have to lift 15 times and drop it. With that jerk, concrete will spread, like see here, spread like this, and you measure the flow. That's called flow table test. So all high workable concrete today we are measuring with flow, not with the slump. This also you have to remember, slump is only for the up to 150 to 160 mm slump, or rather maximum 180 mm slump. The height of the slump cone is 300 mm. So we can measure up to 180 mm. Now once the concrete is totally flowing, slump test is not applicable. We have to go for flow table test. Now that concrete you are already vibrating. So that's why this lifting arrangement has given simulate the vibration effect. And even after 15 drops, we'll say there is no segregation, no cement separation. This is a good concrete. That one has to understand accordingly. You can show this test. We are taken on the field itself. This is the slump this flow test. This is that special tamping rod. 40 by 40 wooden tamping rod. Normal thing, we have steel tamping rod that is 16 mm in diameter and 600 mm length. That is for normal slump test. This is a different test. This is a floatable test. Now we are advising to most of the site, people are using flowable concrete only, to better go for flow test rather than go for slump test. Again, when we are fresh properties of concrete, we'll discuss this test again because it's very, very important test to understand this. And now people are adopting this test for various things that we will discuss during fresh properties of concrete. See this is the initial spread without vibration. Now we'll lift this by 15 times in 15 seconds. See, and then he'll measure the X and Y diameter. That is the specification requirement. So once you vibrate the concrete, it is not segregated. You can see here, all aggregates had come to circumference. Paste is there within the body of concrete. There is no segregation. It is around 62, 620 mm flow. This is general requirement for flowable concrete. Today we must have heard about these columns, whatever we have seen, metro or any other project. The whole column maybe about 6 to 8 meter in height. We are casting in one go. We cannot use slum concrete. We have to use only a flowable concrete. So performance test of the fresh concrete, loss of workability in standing, check the retention of after 45 minutes and up to the placement. So this is the minimum they are given, and depend upon your placement time, you can decide how much time you need for remain your workability. Bleeding, we have discussed. Air content, setting time of concrete is also there. Now setting time of concrete and setting time of cement is totally different. That we'll discuss when we are discuss about fresh properties of concrete. We'll discuss in that in detail what is the setting time of concrete, and then your water content. Now there is a uniformity test also. They are indicated when the admixture comes. The manufacturer will give the requirements, whatever they are tested, and that whether they are within the range that one has to see. The relative density, specific gravity, then dry material content, if it is liquid, or there is a solid admixture also, powder admixture also available. Ash content, fluoride ion content, and pH. These are the requirement for the admixture. When you get the any lot, one has to check all these parameters which is specified initially when you got your admixture. What are the specified the values, and new lot which is arrived at site, and there is a tolerance they are given which is within some certain limits, which is given in IS 910. You note down that, and accordingly you can check this. This is another test to check the compatibility of your admixtures. I'm just showing this. We'll not discuss today. We'll discuss whenever discuss about fresh property. We don't have time now to discuss this test. But I'll show the video of that to understand the concept, and then we can go for I think video is not working. Something issue there. I'll show you later. Okay, this was what we are discussed. That Marchcon video I'll show you in next presentation before we go for fresh properties of concrete. I'll definitely show you that video how to work out, check the compatibility of your admixture with the particular source of cement. That is the simple test which we can perform at project sites, even at project site. Whenever new lot comes, we have earlier sample, we have a new sample, we check the performance and accept the material. So within an hour we will know this, and then only we can proceed. So this is what affecting the clay performance of your admixture. This is mostly effect because of your PCE performance, monomelite clay, and that we can see only in the microscopes, not in the normal guidelines. I think lecture we have covered about admixture, chemical admixture, and there's one or two things which was I think not able to come covered. One is the compatibility of admixture to the particular type of cement we are using. So that is very critical when you are using any admixture. That admixture may be compatible with the particular source of cement. Source in the sense, because suppose you get ACC. So ACC has got various plants. So their raw material is different. Their burning process is different. So the performance of concrete admixture in concrete is different to the source of cement, though maybe it is ACC. So one has to ensure as a QC engineer which source the cement is coming, and that particular admixture is tuned to that particular source of cement. Now the source has changed, you may not get performance in with respect to fresh properties in the concrete. You may not get the slump retention. You may get initial slump, may not get after half an hour. Or you may get initial very high flow. Afterwards, you may not get. Cement may require having similar properties as per the IS standards. IS 269, whatever is there, it is meeting the requirement. But there is a huge range is there in between. And some of the minor component is playing major role for compatibility of admixture to the particular type of cement. So one has to remember when you are using OPC, now suppose you PPC, same admixture may work, may not work. Suppose you use PSC, Portland slag cement, the behavior will be different for the same cement. So one has to ensure, so whenever you are doing any concreting, you ensure the source of cement and source of admixture should remain same throughout the supply or throughout the production, whatever you want to do. It is always advisable that we should have alternate source ready for you for concrete production. Suppose one admixture is available, you can have two sources of cement or three sources compatible with that. Or you can have different admixtures. You cannot depend only on one source of admixture. So we should have two brand of admixture also and two brand of cement. So your production process will continue. You cannot have any issue in between. This exercise basically called as a compatibility of cement and admixture, because chemistry of cement and chemistry of admixture is very, very sensitive for performance. Now, how to judge is, one is you can have a regular concrete, you have a control, whatever mix is there with the particular source of cement and particular source of admixture with the particular dose. And you have work out that I want initial flow so much, and after 1 hour, 2 hours, or 3 hours, you can check that. So you can make a concrete and check it. Another is you can have a marsh cone. This is one of the method to determine the compatibility of cement admixture with only cement paste. Because admixture is sensitive to only cement, cementitious system. Other materials are inert, except if the sand contains lot of clay, that may be reactive in nature. But other cemetery system, you have OPC, you have fly ash, or you have OPC plus you have GGBS, or you have OPC fly ash, microfine materials, microsilica is there, or alcofine is there, or process fly ash is there. So whole system compatible with the particular source of cement for the performance in fresh properties at concrete. Definitely, it will also affect the hardened properties of the concrete. But majorly, it is affecting your fresh properties of concrete. How to determine? There is a one is you can have mini slum cone like this is the only cement paste and check the flow with a particular dosage of admixture. Very small sample, maybe 100 200 grams of cement, make a paste with water cement ratio what you are going to use in concrete and particular dose and check the flow. Now this flow we can check with time, 30 30 minutes, 1 hour, 1.5 hour, 2 hours. If you change the cement, you will find the behavior of flow is changing. So you'll have comparison first, which is there with the control sample. This also tool for checking admixture which is coming on lots. Suppose one lot has come and second lot has come, and how to change, because we don't have any uh, elaborate testing system at site. So such a small test, mini slump cone, we can have that and check the flow and check the performance with time also. And you will find if the compatibility is okay, you will get similar flow with whatever approved sample. If your problem is there with the cement or with the admixture even, the performance may not remain same. In this, one thing you'll have to remember is ambient conditions needs to be controlled, like your temperature, ambient temperature and humidity, because that is also influence on your workability of concrete always. So you have to put it in the laboratory where 27 plus minus 2 temperature is there and conduct this trial to understand behavior of admixture with a particular type of cement. Other test is uses your march cone test. This also IS has specified this test for compatibility of your cement. You make a slurry about 2 liters, put it to this container, and with 5 mm opening, you can find out how much time it takes to withdraw 1 liter of slurry. Take 2 liters, withdraw 1 liter, and take time how much? 40 seconds, 50 seconds, 80 seconds. And that also you can check with the time, keeping other parameter constant. If the compatible admixture or whatever approved admixture gives a particular time with 5 minutes and say 1 hour, or 5 minutes and say 5 minutes, because it has to react with the cement. That's why you keep 5 minutes and take the flow after 5 minutes. Because immediate it may give very good flow, but after 5 minutes you'll have to see. And then you check after 1 hour. And there will be definitely drop in the flow. But that is accepted drop. So sometimes we'll find the flow is not at all flowing to the concrete. This flow is already concrete, as this space become a stiff and it is not flowing to this nozzle, 5 mm nozzle. Then it is not advisable for having a proper admixture and compatible with the particular source of cement. So this is the IS code. They are given this. This is the cone and this is the thing. And this is 2 liter capacity. If you put only water in this at 21 degree, to withdraw 1 liter of water, it takes about 27 seconds. This is your control. Your cone is working okay to check this. And once that is working okay, you go for the straight line up to 30 to 40 seconds and develop your individual grout mix. This is basically used for grouts, but this can be also used for determining compatibly with particular type of cement. Means there is two. One is admixture, one is cement. Now, if you change the cement, the performance will change. If gives the same performance, you can put into the concrete, no issue. But performance change, it needs to do modification in admixture. Because cement is very difficult to modify. Because in a day they produce 10,000, 20,000 ton. So it's not advisable to go back to the cement factory and change the cement. But it is always advisable for admixture fellow who is making your admixture, he can fine tune their admixture to suit the chemistry of cement. So this is one of the method to find out the. So this is, you can see here. This is cement slurry, the March cone, and measure. So this is way you can conduct the test, find out the time, and that time for that particular approved mix, you have to keep this, and accordingly we can check your admixture. Whenever the new admixture comes, new lot comes, you can check their performance. Okay, I think this was the missing last lecture. So this is a very useful test and can be carried out at your project sites.